Hey there, science fans! Ever wondered how your toaster gets so hot and toasts your bread to perfection, or how that electric heater keeps you warm on a chilly night, making your room cozy and comfortable? The answer is a neat little thing called Joule heating, a fascinating phenomenon. Joule heating is like magic, but instead of spells, it uses electricity to work its wonders. It's all about transforming electrical energy into heat energy, a process that's essential in many devices. Imagine a flow of tiny electrons, like a bustling highway full of cars, all moving in unison. As these electrons zoom through a material, they bump into the atoms that make up that material, causing interactions. These bumps create friction, and just like when you rub your hands together, friction generates heat, warming up the material.
Section 4. Harnessing the heat benefits and applications. Joule heating isn't just about toast and light bulbs, though. It plays a vital role in countless applications. Think about electric stoves, ovens, and hair dryers. They all use Joule heating to generate heat for cooking, drying, and styling. In the medical field, Joule heating is used for cauterizing wounds, stopping bleeding during surgeries. It's also used in industrial processes like welding, where high heat is needed to melt and fuse metals together.
Section 5. Too hot to handle. Challenges and problems. While Joule heating is incredibly useful, it can also be a bit of a hothead, literally. This phenomenon occurs when electrical energy is converted into heat energy. One of the biggest challenges is dealing with excess heat, which can be quite a tricky problem to solve. In electronics, especially in tiny, powerful devices like smartphones and laptops, heat buildup can cause performance issues, shorten lifespan, and even lead to damage. This is a major concern for both users and manufacturers. Imagine your computer crashing in the middle of an important task because it got too hot, not cool. Overheating can disrupt your workflow and cause significant frustration. That's why engineers work hard to manage heat in electronic devices, using things like heat sinks and fans to prevent overheating. These solutions are essential to maintain device performance and reliability.
Section 6. Staying cool, advanced solutions. As technology advances, scientists and engineers are coming up with even cooler, pun intended, ways to manage Joule heating. This is crucial as devices become more powerful and compact. One exciting area is superconductors. These amazing materials have zero resistance at extremely low temperatures, meaning electrons can flow through them with no friction at all. No friction means no heat. This could revolutionize how we think about energy efficiency. While we're not quite ready for superconducting smartphones, this technology holds immense potential for future electronics, possibly transforming everything from computers to power grids.
Another promising area is nanotechnology. By manipulating materials at the atomic level, scientists are developing new materials with tailored electrical properties. Imagine designing materials with just the right amount of resistance for specific applications. That's the power of nanotechnology. So there you have it, the electrifying world of Joule heating. It's a powerful phenomenon that plays a vital role in our lives, from the everyday appliances we rely on to cutting-edge technologies. The impact is everywhere, and as we continue to innovate and explore the frontiers of science, understanding and managing Joule heating will only become more crucial. The future is bright and full of possibilities.